Hello everybody and welcome to Campus 101 exam curriculum series. My name is Dr. Piro and now today we're going to be looking at semiconductors. Let me tell you the relevance of semiconductors to your exams. About 6 times out of 10 times in the last 10 years, we have seen semiconductors come out in one form or the other in your exams. I'm not saying it's going to come out in the next exam, but I'm saying that it's a very important topic that you should not neglect. Now, we know that in electricity, substances can either be classified as what? Conductors, insulators, generally. So either you are a conductor and you allow free flow of electricity through you, or you are an insulator and then you limit the flow of electricity by having a high resistance. But we also notice that some substances, some elements on the periodic table, at some points they behave as conductors and in other times they behave as insulators. These substances are particularly located in period 4 of the periodic table. Period 4. So we call them the period 4 element. And the first member of period 4 is carbon, but the other members, and carbon we know under normal circumstances does not conduct electricity except it is purified. But the other elements in period 4, such as germanium, silicon, especially silicon, and gallium. We found out that these 3 substances, under some circumstances, they conduct. These 3 elements, under some circumstances, they conduct electricity, and in other times, they do not conduct electricity. I need you to know these 3. In the exam, they can ask you, list examples of semiconductors: germanium, silicon, and gallium. Easy peasy. Alright, so let's look at, before we appreciate semiconductors very well, I want us to look at the structure of a semiconductor. So I told us they're in period 4. They have 4 electrons in their outermost shell. For those, your chemistry should tell you that. So let's take silicon for example. If this is silicon here, this silicon atom has 4 electrons in the outermost shell. It is connected to another silicon that has 4 electrons in the outermost shell, connected to another silicon that has 4 electrons in the outermost shell. And then it goes on and on and on and on. Alright, so we see the structure of a semiconductor. This is how it looks inside. Alright, now we've also discovered that in some instances, I told us that in some instances they conduct electricity and in other instances they do not conduct electricity. So semiconductors are divided into 2 main types. Alright, so the question I want to pose to you here is, or rather what I want to tell you here is that let us look at this semiconductor in this way. Assume that this structure is represented this way. Alright, it's represented this way. So this is how a semiconductor structurally looks microscopically. How do we change the ability of a semiconductor to conduct electricity? We change it by a process called doping. Doping. Now, pay attention closely. What is doping? Doping is the addition of impurities. We add impurities to elements such as silicon to improve the conductive ability of these semiconductors. And what do we use? So doping, dope, drugs, so in addition of impurities. So we can just use that to remember. Alright, I'm not saying nobody should do dope. Dope's bad. Dope's burn your health. But doping, we dope silicon. It's okay, don't laugh, you can pay attention now. So we dope silicon to improve the ability, its ability as a semiconductors. And what do we use? We use elements that have 5 electrons in the outermost shell or 3 electrons in the outermost shell. Alright, so 5 electrons in the outermost shell or 3 electrons in the outermost shell. So that is what we use to dope. Alright, that is what we use to dope semiconductors. So in some semiconductor we add substances such as what? Phosphorus. In some we add substances such as what? Nitrogen. Alright, so these are impurities that are used to dope semiconductors. When we dope semiconductors, don't forget they have 4 electrons in their outermost shell. They have 4 electrons in their outermost shell. When we dope them with substances that have 5 electrons in their outermost shell, what happens here is that this semiconductor, when we add a 5 electron element as the impurity to dope silicon, what happens to silicon is that instead of having 4 electrons in its outermost shell, it will now have what? 4 plus 5. So it will have 1 extra electron in its outermost shell. 8 electrons are required to fill the outermost shell. When you fill up the outermost shell with 5 electrons, we have 1 extra electron. So this electron becomes, we now label this as an electron. So it has more electrons in its outermost shell. So what conducts electricity in this kind of semiconductor will now be what? The electrons, the extra electrons in the outermost shell. Follow closely. Doping is addition of impurities to semiconductors to increase their properties. When we use an element that has 5 electrons in its outermost shell to dope silicon, what we get is an extra electron in the outermost shell of silicon. Now this electron becomes what will conduct electricity in the structure of this semiconductor. This kind of semiconductors which have extra electrons in their outermost shell are called N-type conductors. N-type semiconductors. Alright? In the same way, there are some, when we use a semiconductor, when we use an element, I hope you can see this. Yeah, good. When we use an element which has 3 electrons in its outermost shell, here we are using an impurity that has 3 electrons in its outermost shell, and we're adding it to silicon that has 4 electrons in its outermost shell. When we do this, what will happen is that the result is silicon will have now 7 electrons in its outermost shell. Now, what we need to complete the orbital in the outermost shell are 8 electrons. Now, what we see is that there's a deficiency of 1 electron. So what will happen is that instead of having electrons in this outermost shell, this semiconductor will lack 1 electron in its outermost shell. And what this means is that it will have what we call holes, H-O-L-E. These holes were supposed to be filled with electrons, right? But now the absence of electrons makes them conduct electricity, and this property, these spaces that are left in the outermost shell are called holes, and then these holes begin to conduct electricity, because electricity is actually the flow of current. So the deficient electron will move from one atom to another, from another atom to another, and then trying to make this 8. Trying to make this 8 will now set up and improve conductive property of this semiconductor. This kind of semiconductors that holes are the conductor of electricity are called P-type semiconductors. P-type semiconductors. So you can remember that with me. My name is Dr. Piro. So Piro-type conductors. All right, Piro-type semiconductors. And from here, the summary of this page is that we have 2 types of semiconductors. N-type. In N-type, electrons are the carriers, and then we have the P-type. And in P-type, holes are the carrier of charges in these semiconductors. So I want you to remember this clearly, because we are going to work on this to build on some new concepts in semiconductors. The next thing I want us to look at is a very important concept, and that is the concept of diodes. Diodes. Everybody say diodes. Diode. So the question I want you to know is, or rather the answer I want you to know as regards your exam is, what is a diode? A diode is formed when we have 2 semiconductors put together. In this semiconductor here, one of them is a P-type conductor and the other type is an N-type semiconductor. All right, so when we link up 2 semiconductors such that in one of them is an N-type semiconductor where electrons are what carries the charges. So let me make this electron. So this red is electron. Now in the other semiconductor, holes are the carriers of charges. This union of a p-type and an n-type semiconductor, this union forms what we call a diode. A diode. This is what forms a diode. A diode, and we can place electrons, we can place charges across this diode. When we place charges across this diode, two things can happen. Either we have, now pay attention closely here. I'm not going to explain this in detail, but I just wanted to mention it so that you'll be aware of it. When we place charges across a semiconductor, don't forget, we can either have a positive bias diode, or a reverse bias diode. When we place charges, we can either have a positive bias diode or a negative bias diode. When we place charges across a diode, we can either have a positive bias diode or a negative or a reverse bias diode. So this is what and diodes can also be called, sometimes they are called junction diode. So in your exam, you can be asked, just write a short note on junction diodes. In that situation, you say this is formed when a p-type and an n-type semiconductor are united and charges are placed across them. They can either be positive bias or they can be reverse bias diode. The next commonly asked question when it comes to semiconductors in your exam is a concept that is known as the dielectric. Dielectric. Now, this is quite different from here, so let's put this together. So I want us to just quickly look at what a dielectric is. I'll just give you the definition of the term dielectric. Now, a dielectric, and you have to pay close attention now, is the maximum potential gradient or electric field. Don't mind my spelling here. Or electric field strength that an insulator can withstand without breaking down. Alright, so a dielectric, now let's take it from the top so that we all get it very clearly. Alright, a dielectric, first off, a dielectric is a substance. Alright, it's something, it's tangible. A dielectric is tangible, and a dielectric is an insulator, is an insulating material. Alright, and this insulating material is used to separate the two layers of a capacitor. So if this were a capacitor, hope you can see this. If this were a capacitor and I put an insulating material, this green, between this capacitor, this insulating material is called a dielectric. Now, what is all this in red that I've written? What I've written in red here is what we call a dielectric potential. A dielectric potential is the maximum potential gradient or electric field strength that an insulator can withstand without breaking down. So this dielectric here, if I keep increasing the potential difference between the plates of this capacitor, at some point it's going to break down. But the maximum potential gradient it can withstand is its dielectric potential. And don't forget, the unit for dielectric potential is what? Is volts per meter. So in summary, we look at semiconductors. We said semiconductors are materials that conduct electricity. Sometimes they act as conductors, other times they act as insulators. We said they are found in period 4 of the periodic table. Examples include germanium, silicon, and gallium. They have 4 electrons in their outermost shell. We looked at the internal structure of silicon, and we saw that sometimes we can improve the conductive property of a semiconductor by adding impurities, and that process we refer to it as what? Doping. And we can dope with a substance that has 5 electrons in its outermost shell, or we can use a substance that has what? 3 electrons in its outermost shell. When we use 3 electrons, what we get is, when we use 3 electrons, we have an n-type semiconductor. When you use 5 electrons, we get a p-type semiconductor. We also said that a junction diode is created when we place in a circuit a p-type semiconductor alongside an n-type semiconductor. We said in a p-type conductor, the carrier of the charges are holes. In an n-type, the carrier of the charges are electrons. We said when we make a junction diode, it can be positively biased or negatively biased. And then lastly, we look at dielectric potential and the dielectric. The dielectric is the material that is placed between the two plates of the capacitor, and the dielectric potential is the maximum potential gradient that the dielectric can withstand before breaking down. And we said the unit is volt per meter. Thank you, and see you in the next video.